All right, so everybody, thank you so much for joining us for Cincinnati Software Craftsmanship today. Just want to say welcome and thank you for joining us. I'm very excited about our talk today on Alexa. I love Jeff Blankenberg. I really enjoy listening to him speak, and he's just a great guy. So really looking forward to that. Before we start, want to make mention next month, join us as well. Troy Woolery is going to be talking about accessibility, web accessibility specifically, but other things like that as well. It's going to be a great meetup there, so be sure to join us. We'll get those details up on meetup.com as soon as possible. And then also be sure to stick around for the end of the meetup. JetBrains has a cool option where you can actually sign up to give away free licenses at your meetup. So we're going to raffle one of those off. But without further ado, I want to give Jeff the stage. Let me add you in here, Jeff.
Oh, there we are.
Excellent. All right.
Thank you.
I will get out of here and give you the stage.
Oh, thank you, man.
Have fun.
Will do. Hi, everyone. Like he said, my name is Jeff Blankenberg, and you may or may not know me. I travel all over the world, all over the country, talking about software development, and I've been doing it for a while, first at Microsoft and then now at Amazon for the last 4 years. But today I'm here to talk to you guys about understanding Amazon Alexa. And it actually sounds like the talk you guys have next month on accessibility with, he said, Troy Woolery is giving the talk. I don't know Troy, but I know accessibility. And if you guys aren't taking an active approach to accessibility in literally all the software you're building, including stuff like this, it's really, really important to think about how you can accommodate as many people as possible. And accessibility is a really important practice. So I hope you guys will check that one out too. Okay, I'm here to talk about Amazon Alexa, something that actually works really well in the accessibility world, because there are a lot of people that can't see or use a phone effectively or the web, but most people can talk. And so it's really nice to be able to allow people to use the most natural gesture they have using their voice. This is something we learn how to do very early on, right? With being children, 1-2 years old, they can learn how to use some simple words. And being able to do those kinds of things and having the power to command your environment around you, right? Turning lights on and off, or getting the song that you want to hear. I have a friend who has a 4-year-old, and he asked me the other day if there's a way he can actually block songs because he cannot hear Baby Shark again, just cannot do it. So unfortunately, there's not a way to do that, but it was really interesting to hear him try to reason out why that was something that should be necessary. Anyway, let's talk about Alexa. What we're here to talk about today specifically is how do we make our own software for Alexa? How do we get her to do the things we want our software to do? So quickly, little self-promotion of my own. Like I said, my name is Jeff Blankenberg. I'm an evangelist at Alexa. You can find me on all of those platforms, same username, @Jeff Blankenberg. And if you like what I have to say today, or you want to know more about building for Alexa, I want to mention that I am on Twitch. It says Monday, Wednesday, Friday. I actually just started this last week. I'm now going every single day from 9 a.m. to 11 a.m. Eastern. So if you want to tune in, see some live software development, and learn more about how Alexa and chatbots and all sorts of other things work, please join me there. I'd love to have you. Okay, let's get into it. So the first thing to really talk about is, what is an Alexa skill? Well, what does that even mean? And I guess the best way to equate it is to think about all the apps that are on your phone, right? There's lots and lots of skills out there, and these are just some examples of those. But they're meant to be thought of the same way you think about all the apps on your phone, right? So there's an Uber skill, there's a Wemo skill, Twitter skill, Audible's on there, Jeopardy, Domino's Pizza, all sorts of cool stuff. And all of those things allow me to interact with those brands and those companies and those businesses in the way that they want me to, right? So in the example of Uber, I can talk to my device and I can order a ride, right? And it'll tell me when my ride has arrived and what my driver's name is and what the license plate is and what kind of the make of car is. So I can do all of that with just my voice without having to open the app and navigate through it. The same thing goes for things like Domino's Pizza, right? If I need to order a pizza, I could just talk into the air and order those things. But these are all pieces of software that these companies built, and they're using their own APIs or whatever things they have behind the scenes to handle all of the interactions that you may have. But they're doing it in a way that makes it so you can just think and talk without having to pull your phone out of your pocket or jump on your laptop. So that's the idea behind what a skill is. So one of the things that's really important when I talk about a skill is that we're going to talk about a concept called intents. And these are probably a new concept for you, unless you've done some chatbot work or something where you're handling some kind of natural speech interaction. But I really like to beat to death the idea of intents because I want you to understand this. This is one of the key things that you'll need to know as you get into all of this. And I'm only going to spend a few minutes here in slides, and then we're going to jump into actually doing, and I'll show you how a lot of this stuff is constructed. But I want you to understand the intent concept. So I'm imagining you've all seen a DVD player before. You can picture one in your head, or you can use the one I have here on the screen. And DVD players have a very specific set of buttons on the front of them, right? This one has an eject button, it has a play button that's also a pause button, and it has a power button. But there's, on other DVD players, if you took the remote away, there might also be fast forward or rewind or even like a menu button, right? So as we think about a DVD player, there's a very specific set of intents that you expect to have when interacting with a DVD player. And that set is already defined in your head. You don't have to imagine, like, I wonder what they could put on a DVD player. You know what's there. You know what you can say and you know what you can do. And you know that with the DVD player you may have in your house, that you don't expect it to be able to give you recipes or check your bank balance or order a pizza or coffee or whatever else it is. You know that a DVD player does a very finite set of things, and it does those things really well, but it's focused in on just being a DVD player. So if we had a voice-enabled DVD player, we might say something like, DVD player, start the movie, or DVD player, play Star Wars, or DVD player, eject the disc, right? Those are all things that we might say. And the same holds true for when we think about intents in voice applications. So with an intent, we'll have something that is the eject intent. We'll have another one that's the play intent. We might have the same thing be the pause intent, much like this button is. So if you say play and then you say pause, or you say, it depends on the state of the video at the time, right? So we can make determinations based on what's going on inside of our code. We could also have a power button or fast forward or rewind. And in all of those cases, we would expect to just say DVD player, fast forward 10 seconds or whatever, right? So those are our intents. But there's more to it than that. It's not just that I have a play intent. It's that I also define a whole bunch of what we call sample utterances. And these sample utterances are the things that we think users might say. So it's not just play, although you could certainly say play. That would be one of our sample utterances. You might also say something like start the movie, or it's showtime, or play Star Wars, or whatever the thing that makes the most sense for your user to say. So we as developers have to sit down and think about what are the things our users might say. And the nice thing about Alexa and using machine learning is that we don't have to come up with all the things. We just need a good representative sample. I often say you need like 7 to 12 sample utterances to really give a good illustration of what you're expecting users to say. So that's intents. I want to make sure that you guys get the idea behind an intent. I have some very defined things that my code can do. And then I have a bunch of sample utterances defined that indicate what kinds of things, when a user says X, I expect that to go to the play intent. When the user says something like Y, I want them to go to the fast forward intent, right? So that's how this all works. So let's get to an architecture diagram. That's a lot more fun, right? So on the left-hand side here, I have a picture of a user, and they have the little thought bubble, and they're saying something to their device, which is up there underneath the word, or above the word audio. So they say something, and just to explain this whole process to you, the way that these devices work, I'm going to mute this one because otherwise it'll hear me the whole time. You say the wake word. In most cases, your device is probably named the word that's under the cloud. I don't want to say it because I'll set your devices off too. But you can say that name, the one that rhymes with Exa, and that triggers something on the device to wake up. It's called a wake word, and it can be that word. It could also be computer, or Amazon, or Echo. Those are the 4 choices that you have for choosing your wake word. And when your device hears the wake word, it can only listen to one at a time. It's very specifically trained to listen to only one. When it hears that wake word, it wakes up and it starts recording whatever else you're saying. So it captures all the words that you said as a waveform, as an audio file, and it ships that audio file off to the Alexa cloud, which is here in the middle of the screen. So that recording the first thing that we do with it is we map it against the language that you've indicated your skill runs in. So if you built it in US English, we're going to use the US English language model to turn that speech, that audio, into text. That's what speech recognition is, right? We turn that into text. And so we analyze all the waveforms and all the sounds that you made, and we try to translate those down into a set of words that we think you probably said. We also apply machine learning to this, though, to make sure that we understand that what you said isn't complete gibberish, and we match against other patterns that we've seen before to make sure that we're identifying the words that you really said, even though you might have said it with an accent or in a weird order or something like that. That's all okay. The last step is to take it to natural language understanding. And the best way I like to explain this is we all have natural language understanding running on board in our brains all the time. You know, if you've ever been in a relationship, you know this, right? What you say is not always exactly what you mean, right? If you were to take the words that you said in your relationship, like, I'm fine, you know that that's probably not what the person meant, right? They don't mean I'm fine. They mean you're in trouble and you need to apologize right now. We can use that natural language understanding inside ourselves to realize what someone's saying based on body language and expression and all sorts of other things. But Alexa only has the luxury of looking at the words that you've used. And so we try to use that machine learning and that natural language understanding ultimately to map to one of those intents that's inside of your skill. So we try to figure out what the user said, and then we try to figure out which intent it is inside your skill that we want to point the user to. It's at that point that Alexa creates this nice JSON document that contains all the information you need for your code to make decisions. It includes things like the user's anonymized user ID, right? So that you don't know who they are, but you know it's the same person every time. You know if they're using a device maybe that has a screen, you know how big the screen is. Or if it has other capabilities, you can look at those things. You can save contextual data. So if this is the third time we're talking, I can keep track of that stuff right in my database and say, oh, this is the third time we're talking, or the fifth time, or I've never talked to you on a Friday before, right? Like whatever kind of analytics you want to use to talk to your users, anything you can gather during a voice experience is something you might be able to want to use for context later. So all of that stuff, we give you all of the context data that you've stored as part of your session, as well as any user information. But ultimately, at the very bottom of it, we'll see that here in just a bit, is what we call the request. And this is what intent does user want to use, and is there any other data that I need to know about that thing? That JSON document is passed to our service, which is on the furthest right here. That JSON document contains everything we need to know to make a decision. But once we're in our code, once we've received that request, we can do anything we want. This is our code running on our server, however we want that to be. So there's no controls. There's nobody saying like, oh, can I call an API in Alexa? You can do anything you'd like. If you need to call a database, if you need to look something up, if you need to call an API, it doesn't matter. Ultimately, what you're trying to do is have your service respond to that request in less than 6 seconds in a way that provides information back to the user about what they should do next. So in the case of the DVD player, if I say, Alexa, no, let's not say that because we'll get things started. So let's just say, play Star Wars. There's two things that actually happen here. The first is it recognizes that's the play intent, and it tells my service, hey, they want the play intent. But there's that extra piece of information, which is play Star Wars. So I actually get the name of the movie that they want to play. Now, a DVD player probably is not a great example for that because unless you have a multi-disc changer or something like that, it might be pretty hard for a DVD player to do that. But for any kind of streaming service, you can imagine how that would be amazing. Now I could just tell it whatever movie I want, it just starts. So that's what we do in our service, is gather that information, build the response that we want to build, and it might say back to you, oh, you don't own the Star Wars movie right now. Now, how did those words get created? Well, that all happens at our service. We build a JSON document that we pass back to the Alexa cloud as our response. And it's pretty simple, but all it really does is tell the user, hey, it tells Alexa, here's the thing I want to say next. And in this case, we take the text that you've provided, we pass it back to the Alexa cloud, it converts that to Alexa's voice, to speech, and it responds back to the user through their device. So as long as you can fulfill that kind of 6-second contract, every time the user says something, you get the information, you make a decision, you pass information back, you can create some very long-running conversations and experiences. That's the process. That's how this all works. So let me show you more practically how it's actually done. So let's actually do something interesting here. So I told the folks that we're going to go ahead and swap some things here. So I'm going to stop sharing my screen for a second, and I'm going to come over to my browser, and we're going to start sharing again with just my browser so we can dig into some things, and I can also see what's going on in the chat now. So if you guys have any questions, this is one of the things that I wanted to mention to all of you, is that I already know everything that I'm telling you right now. That's why I'm here. Thank you, Michael, for getting that all set up. I want you to leave here knowing as much as you want to know. So if you have questions, if you have things that you want to know, I would much rather stop and answer your questions than I would to just go through the same kind of routine that I've done before. And I think that I've got a lot to show you here and a lot to explain, but ultimately I want to make sure you guys leave it with your questions answered. I think that's the most valuable. So don't hesitate to ask if you have questions. But in the meantime, I'm going to dive right into creating a skill so I can explain how some of this works. So I'm at developer.amazon.com. And you can see that there's this extra stuff, Alexa/console/ask. All you need to do to get here is just go to developer.amazon.com. You don't need to follow along now, but if you want to do this later, that's how that works. And all you need to do is create an account. I generally recommend when you log into developer.amazon.com, use the same credentials that you would use when you shop on Amazon, assuming you've done that before. The reason for that is if you have a device, your device is probably set up with your shopping credentials. And if you want to be able to build your skills and test them immediately on your devices, can't recommend enough to use the same account. So you don't have to. No one's making you do that. It's just going to create more challenges for you in the future. You'll have to do some weird account sharing stuff. But if you just log in with your Amazon credentials and build your skills from there, they'll automatically show up on your devices. It's really, really nice. Okay, so creating a skill. That's the first thing that I'm going to do is create a skill. And the first thing we need to do is give it a name. So we'll call this Cincy Soft. I'll just call it Cincy Software. I'm not going to go through the whole name. But this name is more or less a marketing name. This is the name that you'll see in like the skill store, like the App Store. So it doesn't really, there's not a whole lot of value you need to put on that other than that's what people will see. What I do recommend though is think deeply about what you call your skill, because it's really important to have people be able to remember it. I have a whole other presentation called 10 Things Every Voice App Should Do, and we won't have time to get into all that tonight, but I do want to make sure that you guys are aware that like there's a couple of rules you need to follow when you think about how people communicate with your skill, and being as clear and as obvious as you possibly can is highly, highly recommended. So we'll talk about invocation names and how people actually open your skill and stuff in a minute, but think hard about your name because it's important. Also, unless you own the word, your skill can't be named one word. It has to be two at a minimum. Now, if you own the word Starbucks, for example, sure, of course you can call your skill Starbucks. But as you try to publish it, they'll ask you for proof that you own those words. So you can't just like slide it in. You also can't use two words and just happen to have them be Star Wars, right? You can't infringe on people's trademarks and copyrights. So another thing to keep in mind. I'll show you a skill of mine later called the Unofficial Star Wars Databank. That's fine, but you really have to be very clear that this is not affiliated or associated with the entity at all. Anyway, that's way too much about naming. Lots and lots to do there. But you can see that I get to choose a model that I want to use. And so by default, about 99% of the time, you're going to choose custom. This is, I want to do what I want to do, and it's going to be my own way, and it's going to be handled the way I'd like it to be. But there are six others here that I just quickly want to give you a quick overview of. So if you're talking to your device and you say, what's in the news, or start my flash briefing, flash briefing is something that's built right into the app. I'm trying not to say her name, but it's built right into the app. And it allows you to configure a bunch of news sources. So every morning, if you want to hear NPR, and then you want to hear the weather forecast, and then you want to hear sports or whatever, Lady A, there we go. I'll try Tathu TV. I will definitely try. You can configure what your flash briefing is. And a flash briefing skill is a thing that allows you to create and publish your content to make it available for people to put inside of their flash briefings. The second one is Smart Home. Smart Home is a very predefined set of controls, right? On, off, up, down, temperatures, all those kinds of things that you might imagine controlling with a smart home. You don't get to define the intents. Those intents are predefined. What you do is say, when someone says on, what should my device do? And you're building the API connections to actually turn the user's device on or off. So unless you're making smart home hardware, you're probably not going to be building smart home skills. Music and video are very similar. They, again, predefined models, play, pause, rewind, skip, all that kind of stuff. But for music skills and for video skills. And then we have two others. I want to make sure I stay on custom. Meetings, this is what allows you to build your own skills for inside your business. So imagine being able to book meeting rooms or start conference calls directly from devices. That's where you could do that. And then education allows you to do the same idea, but for children in education, so that they can check on their classwork, see what their grades are, get notifications from the school, all that kind of stuff. So again, very, very predefined setup structure. So the intent model is more or less defined for all of those. But custom allows us to do whatever we want. And so I think that's really what is the most interesting to me. Down here at the bottom, and this is another cool thing that I want to make sure you're very aware of, is how I want to host my skill. Do I want to host it as Alexa hosted Node.js, Alexa hosted Python, or do I want to provision my own? So for today, I'm going to choose Alexa hosted Node. And let me explain what the Alexa hosted ones are. Normally, if you've ever built an application ever, you have something that's running on a server somewhere, right? Real nice vague terms. Maybe that's on AWS or Azure, or maybe it's on a server that sits under your desk. It doesn't really matter. But ultimately, you have some server running someplace that's running some of your software. You have to pay for that. So in the case of the server under your desk, maybe it's a very minimal amount of cost, right? You have to pay for the power to keep it on, and you have to pay for the internet to get access to the device. But in the case of some cloud service, you have to pay based on the usage or time running or whatever. So what Alexa hosted for Node and Python offers is the ability for you to set up an AWS service called Lambda, serverless function, that runs your code for you, but you don't pay for it. So Alexa hosted allows you to basically set up an individual Lambda function. It's not on your account. You don't have administrative rights to it or anything like that. But you do have the ability to go in and add code and interact with it and do everything you'd need to do to get a skill running. So that's what Alexa hosted is. If you want to do it on your own, you are more than welcome to. Nobody's making you use Lambda at all. But if you'd like to provision your own and have it living someplace else, that's totally fine. The one pitch I'll make for you on AWS Lambda, though, is that even if you have an AWS account and you start using Lambda as like your own thing, it's still very, very hard to get out of the free tier. So if you have 1 million invocations per month, that means every time someone talks to your skill, that counts as 1. If you can get over 1 million invocations a month, I think you kick in out of the free tier and into like $5 for the next 1 million. So it's still really, really affordable. But I make this offer to everyone, so you guys can hold me to this. If you build a skill and it exceeds 1 million invocations in a month, call me, text me, hit me up on Twitch, whatever. I will come visit you once this whole pandemic thing is over. I'll buy you dinner because that is worthy of a congratulations. You've done something pretty remarkable to do so. Okay, so that's enough about provisioning. I'm going to choose Alexa hosted Node.js for now. This allows me to set everything up here directly in my browser. I don't have to do anything else. Obviously, there's a little more work if you provision your own, but it's not very hard at all. So I create my skill, and the first thing it asks me is, hey, we have all these templates. Is there one you'd like to start with? And you can see that there's a bunch of different examples, and they all have different things that they do. This one has voice permissions. This one has APL for audio, which basically allows me to overlay Alexa's speech, Lady A's speech, sorry, Tathu. I'll overlay speech with sound effects and all sorts of other cool things. So APL for audio is something certainly worth checking out. If you want to just see how to call an API from a skill, you could use the survey skill, but these are just starter kits. I recommend starting with Hello World because it's about as stripped down as you can get. And that's what I'll use here, but you can see there are some other examples if you need something to start with. So I'll continue with that template. If you have a GitHub repository that has your own skill template too, you can import that here. So you can just basically point it at a Git repo and it'll let you pull that in and use it. So this, like it says, takes about a minute. And what we're doing here is we're provisioning that Alexa function. AWS Lambda function. We're also building the skill itself so that we have all of our intents and all of those things are ready to go so that we can start adding to it and start building on top of what the template gives us. I'm trying so hard to not say it, Tathu. I really apologize. It's so hard to not say that word sometimes. While we're waiting for this, are there any other questions I can cover for anyone? All right. Well, again, keep the questions coming if you have them. This is what the developer console looks like. This is basically a starter page. Gives you a nice little checklist here on the right-hand side to show you that all of this stuff has been set up for you. If you built this from scratch, provision your own, none of this stuff would be ready for you out of the gate. So the first thing that I want to jump into is my invocation name. We, by default, using a template, set it to change me, but we want to call our Cincy software. I'm going to save that because that is the name that we will use. These are actually the words that we expect the user to say when they want to use our software. So they'll say something like open Cincy software or start Cincy software. You can see there's a bunch of those kinds of words here. And you can see this is also where it talks about how you can only have lowercase characters. You have to have 2 words. And so there's a lot to think about there, but there's good requirements here down at the bottom. But Cincy software works for me. I'm going to hit build model just so that takes effect. So as you get into this, you'll realize that what we're doing is we're building this training data, this model for Lady A, so that the AI can make intelligent decisions about what's going on. And if we haven't actually rebuilt all of that stuff, then it's going to be basing it entirely on what the previous version was. So all I'm doing right now is providing all of the training data that we have, including the name of my skill, which is Cincy software. And we're going to build out just a small interaction. And then I'll show you a bigger, broader skill and how we can really blow this out to be something much bigger. Soon as my model is trained, this should be done any moment. In the meantime, I guess I can jump over here to my interaction model and show you what my intents look like. So by default, these are the 6 that were created for me. You can see 5 of them start with the word Amazon, and 1 of them starts is just hello world intent. So this is the one default intent that this template gives us. And I want to talk about the other 5 first because those are the important ones. So the cancel intent, if you've ever built an app for almost any other platform, there's always some Chrome or some convention that you need to follow in order to operate on that operating system, right? You need a close button, maybe a minimize button, maximize button, depending on the operating system. You often have to have specific button types, and there may be some common cues that you give your users about where help is or things like that. These are the same idea, except that they're just intents. These are things that are required in order to be able to publish a skill out to the store. So cancel, this means if someone says cancel or something like cancel, that we want to give them the opportunity to cancel based on context. A lot of times people will pair up cancel and stop because they generally mean the same thing. But you can imagine a lot of scenarios where stop and cancel actually mean 2 very different things. So those are separated out, but you could treat them the same if it makes sense for your context. But you have to handle them. That means if someone says anything like cancel or anything like stop, you need to respond to them and say, okay, you wanted to stop this or you wanted to cancel. I've canceled that activity or whatever it might be. Help is another big one. No matter what skill you have, you need to be able to provide contextual help to your users. So if they're in the middle of ordering a pizza, you don't want it to be an about page and just be like, oh, this is a pizza ordering skill. We have pizza, breadsticks, and salads. That's not help. That's about. So when you think about help, we need to provide a response when someone says something like help to give them some help on whatever it is they're doing. So if they're in the middle of ordering a pizza, you should be like, oh, it looks like you're trying to order a pizza. Here's our list of toppings. Here's how you can add other items to your order, but you're helping them specifically with the thing they're trying to do right now. Fallback intent is something that's interesting. This is the intent that you use when the user says something that doesn't match your other intents. It's a place to fall in and be like, I'm sorry, I'm not really sure what you said. Can you try that again? Or I don't think what you're trying to do is something our skill is capable of, right? You can write your errors however you'd like, but the fallback intent is meant to catch those things that don't apply to the other sets of intents that you have. And you can even set the sensitivity on it to low, medium, or high. So if you really want people to have to say the very specific things that you've defined for your intents, then set it to high. But if you want to be a little looser about it and let her have some interpretation, leave it at low. Navigate home is used when we have devices with screens on them, so you can get back to whatever the home screen is for your skill, because we have a lot of nice visuals we can do there. So that's what navigate home is. You control that in the situations where people are trying to navigate back home. And then finally, we have the hello world intent. This is the one that was built for us. This is our first custom intent that we're working on. And you can see this is that list of sample utterances I was mentioning earlier. So in this case, I have a skill called hello world, and I want the user to open it up, and then they say, how are you? And the skill responds with hello world. So these are examples of what they might say. Now, do they have to say one of these things perfectly? Not at all. The user never gets to see any of this stuff. What we want them to do when they're building for voice is to speak the way they want to speak. And we should have enough utterances and enough machine learning behind the scenes to be able to accommodate those things. So one of the recommendations I always give to people when they're thinking about building for voice is talk to other people. I know I'm a developer. We tend not to try to have conversations as often as we can, but it's really, really important in this case. You want to hear how everybody's going to ask that DVD player to play the movie. Everybody's going to use different words in different orders. And you really want to think about what are all the kinds of variations that I should expect to see. By doing that and then filling out your sample utterances with a good representative sample of those, you'll find very quickly that your skill can lock in and really get a good feel for how these things work. Another cool thing that's in here while we're talking about sample utterances is this evaluate model tool. And I like to show this because if you like doing unit testing, this is a good way to start thinking about unit testing your skill, at least the interface. So in here I have the utterance profiler. So if I say, let's say like, hello there. So you can see hello there is not in the list, right? But if I say submit, it says, oh, based on what you said, I think you want the hello world intent. That's pretty easy and obvious. But we can take this a step further. We can say, let's build an annotation set that is, these are our tests, right? And we'll say, these are the hello world tests. And so I want to create a new utterance. So we're going to say hello world. And we'll add that to our test. And then what we're going to say is we expect that it's going to hit the hello world intent. I don't have any slots for this one, and I don't need to add a timestamp. So I'm going to go ahead and save this annotation set. But when someone says hello world, it should hit the hello world intent. I might also, what if I say goodbye? We'll add this one as well. Now, it shouldn't hit the hello world intent. I actually think it's going to hit the stop intent, because that often means for most people, like, I'm ready to go. I want to get out of this experience. So I'm going to assume that it means the Amazon stop intent for goodbye. So let's save that. And then I'm going to come back to this tool here, and I'm going to choose from my list of tests, I'm going to choose the hello world tests, and I'm going to run that. Now, this will only take a second or two to run. But what it's doing is it's taking each one of those messages and banging it against my model, my interaction model that we have here. And you can see it passed. So inside here, I can see that, yes, in fact, when they said goodbye, the Amazon.stop intent was triggered. That means that my code will receive that JSON document that says, hey, they want the stop intent. And in this case, if they say hello world, they will hit the hello world intent. So both of these pass, and this is saved. So I can come back and run this anytime that I'd like if I feel like I've changed my model a lot or whatever. But you can create a bunch of different annotation sets so that you have some. Here's a good example I'm going to show you in a minute. I'm building a skill that's an entire casino. So you can play video poker, you can play slots, you can play roulette. I'm eventually going to add craps and blackjack and a couple of other games. But you can imagine how I might have an annotation set that's specifically for slots, and another set that's just for poker, and another one that's just for roulette. So we'll see that as we get into it a little bit. But I wanted you to just see how this testing tool worked. And as I come back to my intents, as we look at the hello world intent, we can add as many of these things as we want. So if I say hello there, boom, it's added. I didn't have to do anything extra. All I had to do was add it to this list, save and build, and we're done. So once you've made your changes, it takes about a minute to really get back up and running. So we have this. There's one other thing that I want to add, though, and that's I want to be able to know what the person's name is. So they might say something like, my name is Jeff, right? So I can add this to the list like this. But then I'd also need my name is Mike. My name is Tanya. Right? You can imagine this gets really, really messy after a while. I have to come up with every possible name, and I have to add all these things so that it knows what's going on. So what's cool about this is that I can just take the Tanya here, and we can create what we call a slot. I know I mentioned that earlier when we were talking about Star Wars and the DVD player, but I want to show how this actually works. So I'm going to create a new slot, and I actually want to call this name. So I'm going to hit add, and you can see that now it says my name is name. So I'm going to get rid of these other two because they'll end up just being duplicates. But down here at the bottom, you can see that I have a slot called name. The next thing that I have to do is come up with what kind of data do I expect that to be. So we have a bunch of built-in ones. In fact, there's one called first. There's Amazon.first name, but there's also Amazon US first name. US first name is all of the names you would generally expect an American person to have. That does not mean in any way that it's just like white people names or any specific collection or generalization about Americans. It's names you generally see in America. And when you think about Great Britain, right, they have a slightly different set of names. And when we think about Germany, they have a very different set of names. There's a lot more Hanses and Heinz and things like that. So this allows you to just create it's using a pre-built set of data that we already have that is basically a list of all of the common names you find in that country. Amazon first name is actually one I haven't seen recently, so I don't know if this is a new addition, but I don't know how to explain this one because I don't really know how it works. But as another example, if I choose city, right, we have a bunch of training data here. You can see that I have German city, Europe city, Great Britain city, US city. The cool thing about this is that it's not a list of cities in those places, which is initially what everybody thinks. It's a list of cities in those places that the people there talk about. So in US city, you're certainly going to see on that list places like London, Paris, Sydney, Tokyo, right? That kind of stuff, in addition to all the US-based cities. But in the Europe city, you're going to see most of the European cities, but you're also going to see New York, San Francisco, Dallas, like the bigger named cities that you would hear of in the United States, but also Tokyo and Sydney and things like that. So it's training data. It's gray and it's fuzzy, and there's a good chance that just because we say it's GB city, it doesn't mean it's just a list of cities in Great Britain. I just want to make sure I'm really clear about that. So I can choose a pre-built slot type, which is all these Amazon ones, which I'm going to do for this. I'll just choose US first name. So this is good enough for me because I'm just choosing a name. But I do have the ability to build my own custom slots. So let me save this really quick, and I'll show you what a custom slot looks like. So I have slot types here, and I could say add slot type. I'm going to call this one color. And we'll say next. And then I'm going to say red, orange. Oh, it's even suggesting things for me. Yellow, blue, purple, violet. Right? So I have this list of values, and I'm creating a set of training data that is the kinds of things I expect them to fill that slot in with. So if I said my favorite color is, and then I put this color in there, we'll do that here in a second, we would be able to let the user not choose from these, but say something that matches whatever pattern this reflects in Alexa's machine learning engine. So in this case, you can see it probably is going to be a list of colors. But if someone says light green, it'll still work. It'll still pass through light green. And it's up to you as the developer to figure out, what do I do with light green? That's not a color I was really expecting. Okay, so we have our slots. If I come back to my intent and we look at that hello world intent that we were looking at a moment ago, you can see I say my name is name, and I'll also do a my favorite color is color. Now I'm saying that I want to call this slot, but I haven't actually told it what it is. Remember, we chose Amazon US first name for name. If I look in the slot list now, you can see that color, the one I created, is right here too. And so I can just assign that. We can hit save, we can hit build, and once this is done building, we'll be able to talk to our skill. I'll show you the testing tool that allows us to do this, And we'll be able to see exactly the values that are coming through. We'll see those JSON manifests that are passed back and forth between Alexa and our code. So while that's loading, I'll just open up a new tab here just so we can keep everything in the same place. Okay, so this is the test tab of the developer console. And in here, this is what we call the Alexa simulator. So this is what allows me to talk to via chat or via voice my code. So in this case, I'm not going to use voice because it's more reliable to be able to type it because I know I get everything right. But I highly recommend if you don't have your own device, this is a great way to work. There's also apps on your phone, just the standard Alexa app. And in there, you can talk to your skills the same way. So we want to say open Cincy software. That's the name of our skill. And so I don't know if you can hear the audio coming in, but she is actually talking. I can hear that. But in here, this is what she said to me. So I can see it as a chat conversation, so I can work silently. I don't have to have audio blasting everywhere. But she says, you can say hello or help. What would you like to try? So you can see first, if I scroll to the bottom of this, that I got a request that is a launch request. This is what happens when the user just opens your skill and doesn't say anything or do anything else. They just want to get in. You receive a launch request. This says, hey, we're supposed to start and do some interesting things. So this is what the launch request is. But if I say, my favorite color is red. Now it's saying hello world because that's what our intent is supposed to do, and I'll show you the code for that in just a second. But what I want you to see is down here at the bottom. Again, there's lots of data in here. We have things like that anonymized user ID. We have what the viewport of the device they're using is. We also have system level data about the device, what capabilities it has. That's what this supported interfaces is. But then we have our request. And the request is the really useful part because this lets us know what the user wants to do. So in this case, we know it's an intent request, not a launch request. And we know in here that the intent is the hello world intent. So we've already clarified, hey, this is the hello world intent. This is what they want to do. Now, you may be looking for all of the words I said, right? My favorite color is red. What you're going to find, though, is that you only receive slot values. Because of the way we structure this, we have all of these intents and these access points into our code. We don't provide developers with all of the words that the user said. We provide them with the keywords that you need to differentiate the experience. There's a whole host of security and privacy reasons why we do this, but ultimately, you should be able to build just as compelling a skill without knowing all of the words the user said. So in this case, I say my favorite color is red. I receive only red. That's all I see is that the slot color that I defined, it has the word red, and then I have all these resolutions down here. This resolutions node shows me that, in fact, they matched one of the values that was actually in my slot. Remember, I created a slot that had all the colors of the rainbow, red, orange, yellow, green, blue, purple, violet. So it found the color red. If I open this skill again, because I closed it when I did that, but if I say my favorite color is lavender, I want you to see that this time, hello world intent is what I hit. I hit lavender. That's what I said. The value you see here is what I actually said. But then you can see that it actually says no match this time because lavender isn't actually in my list. There's no way for me to know that lavender matches something because it isn't already defined in my list. And so I'm able to then say like, oh, well, they said lavender. I can use that word, but I don't actually know what that is. So in the case of like setting a background color or something, maybe you have some kind of mapping, or maybe you could try to turn that into a hex value or whatever. Again, you could do whatever you want in your code, but we need to figure out what to do with lavender because it didn't actually match something we expected. So we could push back to the user and say, oh, lavender isn't a color we support. Could you please give me one of the colors from the rainbow? Or you could say, we only take primary colors. Can you give me one of those instead? Or maybe you say lavender, that sounds a lot like this. I'm going to use that instead, right? It's up to you how you want to handle this depending on your use case. But ultimately, you need to figure out how to use a word that you weren't expecting in a creative way. So this is how that works, right? This is me calling my invocation name. My skill responds. I identify that they want the hello world intent. I respond. They say my favorite color is red. I recognize that's the hello world intent, and I respond in kind. So if we look at the code for this, it's remarkably simple. And I should clarify that I'm using the Alexa SDK for Node.js that we've created. We also have one for Python and one for Java. But this simplifies things a whole bunch. Ultimately, what you would be building is a JSON document. So this makes it much easier to do that without having to think about and construct a JSON document on your own. So what I do here is I have chunks of code that look like these. This is what's running in my service, whether that's the Lambda function or wherever else you want to host it. I build these nodes, which I call handlers, and they're meant to handle specific scenarios. So in this case, I have two methods in each one of these. This is all part of the SDK. The first one is called canHandle, and this is what identifies what it's capable of doing. So if the request I received is a launch request, then we want to do something. And that's what the handle function is. If the canHandle returns true, then we do whatever's in the handle function. And you can see that that pattern kind of repeats itself over and over and over as we go down this page. So if the canHandle is true, then we're going to do the handle. And the way it identifies each of those functions is down here at the bottom. We list out all of our handlers. And it actually works in the order that it finds them in this list. So it'll start with the launch request handler, then it'll do hello world, then it'll do help, then it'll do cancel and stop. But ultimately, it's just working its way through here until it finds something that it can handle. And so in this case, of our launch request, it says, welcome. You can say hello or help. Which would you like to try? But when we did the hello world intent, that's where it came back and it said hello world. So let's change this to Cincy Software. Hello world, Cincy Software, just to save this. And then I will deploy that code back out to the server to make sure that it's running in production. Again, I haven't published this skill, so no one's using it yet. This is obviously not something you'd want to test in production, but we've deployed our code. So now if we come back to our test tool, we say open Cincy Software, get the same response. But now I can say something like, my name is Jeff, right? So one of the other utterances we built. So we said Cincy Software. Great. Okay, so that was a very static thing. So let's talk about how we could do this in a more meaningful way. What if we said, hello, Jeff, right? That would be kind of cool to do. So let me show you how we do that in code. Because again, all I'm doing here is building a string. This string could be constructed in any way that I see fit. Once I'm in my code, I can do whatever I'd like. So let's do this. I'm going to add the reprompt. This is the one last thing I really want to talk about before we put a bow on all this. But if you guys have any other questions, please feel free to drop them in the chat. So instead of hello world Cincy Software, I'm going to just change this to hello Jeff. Now I'm not going to hard code it, right? Because that wouldn't be nearly as fun. What I will do is something like this. So I have handler input got request envelope. And now I have to remember what this actually is. So let's scroll down. Request envelope, and then I'm going to say dot request dot intent dot slots. So let's go back and do that part first. Dot intent dot slots. Make sure I get this right. Slots is, that's fine. I can say slots dot color. Now slots dot name. Oh yeah, because name is the one that I want. Slots dot name dot value. So I want slots dot name dot value. So we should be able to come in here, slots dot name dot value, like so. And what this should do is grab that value right out of that JSON document and allow me to respond to the user. So before we do that, I'm going to answer accidental developer's question here. How difficult is the process for deploying a skill to production? It's remarkably simple. What I just did is sufficient. And I'm doing everything here in the browser. It should also be clarified that all of this can be done locally from the command line. There's a lot of local debugging stuff. So if you want to actually run your service locally on your machine while you're debugging, it makes things so much better and faster. You can do all of that. All of that stuff is available and possible. I like to show it this way because it's super clean and easy to understand, and we don't have to worry about like navigating the CLI and working in tools that you may not have seen before. But all the local development story is there for sure. Deploying it, if you're using the CLI, is as simple as typing ask deploy, and it'll take your model, it'll take your Lambda, and it'll push everything to where it needs to go, assuming you're using Lambda. If you use your own hosting, it's just a matter of taking your code and getting it running on that server. But there's two pieces to it, as we've seen. There's the front end, which is the intent model and interaction name and all that. Invocation name. And then you have your back end. And so it's just a matter of pushing those two things to their appropriate places, and you're live. The catch is, if you want to change your front end, you have to go through certification. And so certification can take 24, 72 hours. And so it's much like pushing a mobile app through an app store. You need to make sure that you're checking all the boxes, following all the rules, you don't have broken software, right? Because to get through certification takes some effort. So you'll want to make sure you're keeping all of that in mind as you go through it. So Michael, good question. Thank you. Okay, so we have this hello, and we have the ability, when you click deploy in this UI, does that already deploy to a non-prod testing endpoint, or what does that do? So the thing that we're not seeing, and I can show you this a little bit in a second, AT9, is that as I'm building right now, I only have one deployment environment, which is dev. But once my skill has been published once, I end up with two. I end up with a development environment and a production environment. I can change the production backend, the code side of things, as frequently or as often as I'd like to. But I can't change the interface. I can't add a new intent. I can't do any of that kind of stuff without going through certification. So when I click deploy here, what I'm doing is deploying to my development environment. But if I want to push to my production one, I would have to go into the production version of my skill and edit code there. Or again, most of the time you're probably working locally, at least I hope you are. And if you're working locally, you do all your development here, and then when you're ready to deploy, then you deploy it directly to production when the time is necessary. So hopefully that answers your question. But when I'm clicking deploy here, it's pushing it to my development environment, which is just my development Lambda. Okay, so we have our hello world intent handler, right? Speak output says hello and whatever name I provide. And then we have this bit, and you can see that this is at the bottom of each one of these. This is the process inside the SDK that assembles that entire JSON document for us. And I want to make sure you really understand how this all works before we wrap up. And hopefully, just by typing that, it'll work as my final demo, and we'll all celebrate and applaud, and it'll be awesome. So never mind the first line, the handler input.response builder. That's just the engine that builds the things that we need. But the first function I call is .speak. Speak is the thing that we want Alexa to say. So when we open a skill and we say something and it says something back, it's using that speak function. It's going to say whatever's in that variable, speak output, which in this case happens to be hello, Jeff. But on the top one here, you can see it says welcome. You can say hello or help. So it's whatever speech you provide inside as a parameter, that's what it will speak. There's a second function, though, which is reprompt. And this is a really important thing to understand how it works. If you don't include it, Alexa's going to speak and then be done. So it's basically like, imagine like a fact skill. Hey, give me a fact. And it goes, all right, cats can fall from up to 30 feet and still land on their feet. And then it closes the skill because all you wanted was a fact. You didn't want a conversation. You didn't want to be able to ask for more. Just give me a fact. That's what the experience is like when you don't provide a reprompt. But when you do provide a reprompt, this is where you enable the capabilities to have a conversation. Now, there's two reasons for this. I want you to think about having a conversation with any person ever. You talk to them and you say something like, hey, what's the weather outside? And they just stare at you blankly without having any kind of real response for you. You're going to say, I'm sorry, maybe you didn't hear me. Is it going to rain? Do I need an umbrella? I'm concerned. I'm wearing suede today, right? You're probably going to clarify why you're asking, but you're going to ask the question again. And if they don't answer your question again, they just stare at you, you're going to find somebody else. You're going to move on. You're going to go have a conversation with someone else. That same experience, that same model is modeled here. So in this case, with a reprompt, what I'm saying is if I say something to the user and I'm expecting them to respond to me, but they don't, maybe they walked out of the room, maybe they got on the phone, maybe I didn't hear them. The reprompt is the thing I say only if I didn't hear them the first time. So if Alexa says, what would you like to do next? And I say nothing, she'll come back in and say, I'm sorry, I didn't get that. What would you like to do? Right? It's a way to reprompt the user one more time before we decide to shut off the conversation. But if after I reprompt them, they don't say anything again, then I close the microphone and I shut everything down. This is, again, a security precaution so that someone doesn't build a skill that just sits open listening to you all day. But instead, if you don't respond to it, it will automatically close. You can always say things like quit, and it'll quit the skill immediately. But not everybody realizes those specific keywords that can jump out of things. So we want to make sure the microphone doesn't stay open indefinitely unless you choose to by engaging it. Okay, so let's add a reprompt here that's more interesting than the default one. And let's just say, what did you say? Okay, so that'll be how we do that. But generally, I like to repeat portions of my speak output. So let's do this. Speak output. Like that. Okay, so now I have, it's going to say, hello, Jeff. And then it's going to say, if I don't respond, it'll say, hello, Jeff, what did you say? Now, the simulator that we're using doesn't do that. It doesn't reprompt you. It's going to sit there and wait forever because it's assuming we're developing. So let me save and deploy this code. And I'll show you how this works with a device. Because I mentioned earlier that if I build my skills in my account with the same credentials that I use for my devices, they work automatically, and that's true. So we called this Cincy software. So as soon as that is deployed, and it has, Alexa, open Cincy software.
Welcome. You can say hello or help. Which would you like to try?
My name is Jeff.
Hello, Jeff. Hello, Jeff. What did you say?
Stop. So you can see how Goodbye. So you can see how I simply captured the value that came right out of that JSON document, use that to respond back to my user. But of course, I could do more interesting, more compelling things than that. And then I was able to respond back to the user and also provide a reprompt so that I could continue talking. So that's kind of the quick and dirty on how we build an Alexa skill. Obviously, this could get way more complicated. And what I'd like to show you really quickly, if I can do this, is I have a skill in here that I'm working on. I mentioned I'm building that casino skill. So let's take a look at the model for this first, just so you can see what a more advanced model looks like. You can see that I have things like the balance intent and poker hold intent and poker deal, spin roulette, bet summary, start poker. These are all different kinds of intents that a user might want to have. And they all do very different things. So in the case of start slots, right, they can bet. So they could say, bet 5 coins on slots, right? This is a good example of how that stuff might work. Or play slots for 5 credits. So all of these are games that we can play. And I'll show you how they work. And then if we want to dive into the code, if we have time, we can do that. Alexa, open Chatcino.
Welcome to the Chatcino. What would you like to do?
Bet 5 on slots.
You got orange, cherries, orange. That is not a winning spin. You lost 5 coins. What do you want to play next?
Bet 10 on poker.
You already have a pair. You were dealt ace of spades, jack of diamonds, 10 of clubs, 8 of clubs, and 8 of spades. Which cards do you want to hold?
Hold the 8s.
You are currently holding the 8 of clubs and 8 of spades. You are about to drop the ace of spades, jack of diamonds, and 10 of clubs. You can say deal to finish this hand, or you can continue holding cards. What would you like to do?
Deal.
You won 20 coins with a 2 pair. Your new balance is 1,394. Your final hand was king of clubs, king of hearts, 8 of clubs, 8 of spades, and 5 of diamonds. What do you want to do next?
Quit. All right. So hopefully that kind of gives you an illustration of how we can be much more advanced, right? I was telling it how much I wanted to bet. It was telling me how many cards I had. And if I show you here what this all looks like, I'm actually using a service called Airtable behind the scenes. You guys may or may not have seen this before, but it's a fantastic cloud database solution that I use for a lot of this kind of simple stuff. So you can see I have a user table. Right now I'm the only user. That's my balance. I have individual game records. All of this stuff is happening, though, in my code. I'm making calls into the database, saving records. If you look at like video poker, this is the the array of objects that is the opening hand and their closing hand. So I can actually see if I open this, like this is the hand I just had, right? So I had the king of clubs, the king of hearts, the eight of clubs, the 8 of spades, and the 5 of diamonds. So this is the object model that I'm using to be able to manage and hold all of that stuff. And then, of course, I also have to have the rest of the deck, right? So that if I needed to deal them more cards, I could do that. So I save all of that stuff in here. But all of this stuff is happening behind the scenes, right? So all I'm doing is talking to the device, but it's able to go in and grab the information that it needs, do the appropriate thing, and move on. And so as we look at this, if we look at our intents, I used a number of them there already. So I had start slots. That's where I just said bet 5 on slots. This was the start poker intent. Start roulette's a little more involved because I have to make bets on specific locations. It all works. I haven't published this skill yet if anyone's trying to use it, but it should be published in the next couple of weeks. Start roulette lets me start a game, right? Bet 10 on red, bet 10 on odd or whatever. Poker hold intent. This is when I said hold the 8s. You can see that this one looks like this, right? Hold all the cards, or shoot. Let's see if I can get that back. Yeah, so I can say like hold the 8s, or the jack of spades, or whatever, right? So those are all different ways that I can imagine a user asking to hold a card or a set of cards. And what? Oh, that's what I did. I was trying to figure out why I just screwed up my camera. And I just figured it out. Anyway, so that's the poker hold intent. That's how that works. But all of these intents have specific purposes, right? So the poker deal intent, that's when I said deal. So it just has a couple of intents like finish the hand or deal the cards or whatever, right? I don't need any slots for that kind of stuff. But this gets big and robust. And if you guys want to see the code for this, by the way, I have a GitHub repo. I mentioned I'm Jeff Blankenberg just about everywhere. And I'd love for you to join me on my Twitch channel or on GitHub or whatever. But right in here, if we look at my repositories, I have one called Chatsino Alexa. This is the one that I've been working on. This is what I'm building live on my Twitch stream, by the way. Let's see if I can. Oh, there we go. Okay, I'm back. Sorry about that. So so I have this GitHub repository called Chatsino Alexa. And in here, just because I don't have the source code on this machine that I'm demoing from right now, I just wanted to show you what this looks like because I'm deploying separately. This is not in the code tab that you'd see there. So you can see I have a lot of the same stuff, right? I have these same can handle and handle, but instead of doing all of my logic here like we did in that earlier sample, what you can see is that I'm actually calling out to separate code. So I have this balance intent or the bet summary intent or the poker deal intent. And so as we go back up the tree a little bit and go look at inside my Lambda, we look at my handlers. I have poker deal intent as an example. And in here, what I'm doing is I'm calling into some logic that is my Chatsino logic. I'm building this module, this Chatsino piece, as the engine that will run behind a Twitch chatbot, a Discord chatbot, a Slack chatbot, Alexa, like pretty much any place I can use it. I'm going to build the front end, which is just the chat or voice interface, but they're all using the same stuff behind the scenes. So all I do is call in, I say, hey, deal poker for this user. And it'll either let me know like, hey, I just completed that thing for you, or they don't have a game right now. I can't play poker for them right now. So those kinds of things just get fed back out. So you can imagine there's a much bigger architecture here, lots more code, many more files. It doesn't have to be as simple as what we saw in that first example. But it is 7:08. I've been talking for an hour. If there are any other questions, I'd be happy to take them. But if not, I'll just thank you guys all for having me. I really appreciate being here. Thank you, Michael. Oh, let's see. Yakbone has a good question. What course or content would you recommend for more Alexa Dev Console info? So the thing that I would recommend is something we call Alexa Cake Time. This is really our getting started tutorial. It teaches you a lot of the stuff that I covered at a high level today in much more depth, but it walks you through like, how do I collect my slots? How do I use persistent attributes? How do I save that information so I remember it from time to in the future? How do I publish my skill? How do I do all that stuff? So I think I can't actually put it in the comments, but you can go to alexa.design/cake time, and that will take you to, pretty sure that will take you right to it. I am correct. Alexa.design/cake time will take you right to that demo. What Alexa skill do you use the most?
I don't know that one.
I know. What skill do you use the most frequently? That's hard to say. There are a number that I use, but a lot of them fall into the smart home stuff, right? Like I've got all these crazy lights going on behind me. Alexa, turn off Office. Right, and that all goes away. So those are all individual smart home skills that are talking to their individual hardware. The light bars that all the rainbow colors, those are from a company called LifeX. This little bulb right here is made by Amazon. That was going on. I had an overhead light, which is made by Belkin. So those are all individual skills that are all happening at the same time. I can turn that all back on too. Alexa, start the Office nonsense. And it all comes back on. So that is how we do smart home skills, right? That's what I probably use the most. As far as other skills that I use pretty regularly, I really enjoy the Jeopardy skill. Being able to play that game is kind of fun from time to time. There's also a number of kind of utility things, right? Being able to order coffee from Starbucks before you get to the store. So you just walk in and order, but you can order from your kitchen counter or from your phone as you're on the way. And you don't have to like open up an app or do any of that stuff. You just talk. So there's a lot of those kinds of utility things as well. I think that's probably a sufficient list. And then the last question was, can a skill be used to interact with Amazon's New World MMO game? I don't know anything about New World yet. So I don't know, but if it has an API, you can do it, right? That's the beauty of what's going on with Alexa here, is that if there's an API, if you have access to it programmatically, it could do it for sure. All right, Michael, I've done enough talking. Thank you.
Thanks, Jeff. Yeah, that was fantastic.
Thank you.
Thank you so much for speaking today, and I really enjoyed your talk. If you all enjoyed it as well, I hope that you will follow Jeff on Twitch and all the other platforms that you mentioned earlier. Check out his stuff; it's really impressive. As we just saw with the Chatino, I like that a lot.
Thanks.
So you should see in the chat, if you want to win the JetBrains license, just type in a message with the hashtag JetBrains, and that will put you in the drawing for the giveaway. Also, you can RSVP for our next meetup. I'm going to drop that link in the chat right now. So check that out, and if you once you can do that. Also, we're really excited to announce the Cincinnati Software Craftsmanship. We just recently reached 1,500 members, and we really appreciate all of you being a part of our group. So we'd love to hear your ideas on how to celebrate this milestone. We'd also love to hear your ideas on, love any feedback you have on how to make our meetup even better. We're really excited for what we have here, but we never want to stop growing and improving. So if there's any topics that you'd like to hear about, or if you'd like to speak at CSC, then please let us know. We'd love to get in touch with you. So in just a moment, we'll be meeting on Zoom if you'd like to join us, and I'm going to drop that link in the chat as well. I'm doing that. Jeff, is there anything at the end you'd like to say? Is there anything in particular?
I don't think so. But for those folks that are here on Twitch, I would always appreciate a follow. I'm building stuff for Alexa and chatbots every single morning from 9 to 11. It's a nice way to start your day. Just tune in the background, ask me questions, whatever. I work for Amazon Alexa, but I also really enjoy building a lot of this stuff. So if you have questions about anything, come find me there. I'd love to have you. We just hit 500 followers. I did an entire episode dressed as an X-Wing pilot. And so people are trying to come up with ideas right now for what we should do for the next milestone, whatever that may be. So that's it. I just want to make sure that you guys know how this stuff works, and that if you're interested, you have an opportunity to do it.
Excellent. Cool. All right. I'm going to go ahead and quickly draw the winner of the JetBrains license. All right. It looks like Rohit is our winner for today. Rohit, just if you can contact me or message me in the chat or however you want to do that. And I just want to say thank you all again. And it's really been a pleasure. And I hope to see you on the Zoom call. Thank you. See you all.
Bye, everybody.